Ilaria, let me know when I arrive at 8 minutes, because... Okay.
Fatemi sapere quando arrivo a 2 minuti dal mio tempo.
So, welcome everyone. Today I will present some sort of technical presentation that is pertinent to analysis that we carried out for the Aprie, for the province of Trento. We developed a tool together with Sara, I don't see Sara, and Luca, okay. Luca, sorry, your name is not here because it is the same title that we used for the conference, and you decided to don't participate. So. But in any case, Luca was very, very helpful in this. The idea was started, the idea of this cooperation started because there was the idea to implement a possible solution for the heating of some communities, some small towns in the province of Trento, because there is a large part of this region, the part in white, that is not reached by the natural gas network. So in this case, there is a specific problem related to the heating, because most of the people there is a wide variety of alternative solutions, including biomass, of course, but also liquid petroleum gas or diesel fuel for producing heat that is very relevant in terms of emission. And so it is important to try to reduce the carbon footprint, but this was not an easy way to do this because the heat pumps were not feasible for this type of solution due to the very high temperature difference, and then probably use of biomass could generate some problem related to sustainability to the use of biomass, at least in long term. So the idea was to understand, to try to examine the problem and try to solve the problem itself by using hydrogen. And then we started to make this analysis, trying to define different type of scenarios that could be pertinent to this type of the problem, because in the different town we have in different town villages we have different problems. So we started our analysis by examining the situation in Trentino, and together with the group in the province, we indicated 3 typical different scenarios that you can see here. I don't know if you see, okay. These are the 3 scenarios that we analyzed. One is Peio, that is a small town where we have a number of different boilers, civil boilers, so one per any building. Okay, I don't know why it is going. I don't know if someone in the back is working on this. And then in this case, the idea is, okay, let's try to understand if it is possible to generate a grid, an hydrogen grid, to feed all the houses. And in the second case, we worked on Ronzo Chienis, that is another small village, I don't know how much small, but a small village where there are a small network of natural gas, based on the use of liquid natural gas, and then passage into the grid, where we examined the possibility to implement a sort of blending, 10% and 20%. And the final scenario we analyzed was pertinent to San Martino di Castrozza, where we have this district heating that was fed by primarily by using biomass, but for the peak time there is a diesel boiler that is producing the needed heat. And in this case, we just tried to examine what happened if we substitute hydrogen with to the diesel fuel. So these are the 3 scenarios we examined. We developed a model, a tool that was based on the implementation of photovoltaic plant and a station for production of hydrogen and storage, together with the final uses. The idea was to try to establish preliminarily the demand of hydrogen in the 3 different configurations, and we do this by assuming that we started from some raw data based on the use of the fuel in these 3 different scenarios. It was a long work just to extract and manipulate this data. And at the end of the story, we understood that for the 3 different scenarios, we had different requirements in terms of hydrogen in tons per year with a different coverage. In none of the cases, at the end of the story, we substitute completely the existing solution with pure hydrogen, because otherwise it could be very difficult to find the total amount of hydrogen. So here you can see a number of relation on how we understood the need, and also how we produced the hydrogen. What we can see is that in the basic scenario, though we don't have, no, in the basic scenario we worked by using a photovoltaic plant, an electrolyzer, a low pressure buffer where we stored the hydrogen for the daily production, compressor and high pressure storage, and finally end users. Okay, nothing more on this. In order to understand really what is the real need of hydrogen, and especially in order to understand how big should be the storage, we decided to develop a tool that was able to take into account from a dynamical point of view the production of hydrogen and the consumption. Of course, we can start just saying, okay, during the year I need 1 ton of hydrogen. I produce 1 ton of hydrogen, store it, and I use during the year. But in general, we have a continuous production, continuous consumption. So it is possible that the total amount of hydrogen that I have to store, the maximum amount of hydrogen that I have to store, is not as big. So the idea was, okay, let's try to compute something using a time-dependent tool that is able to take in account the radiation that we have on the soil, and the production, and finally the end users. So we developed this code in MATLAB Simulink, and on the basis of this, we were able to understand the characteristic of the different scenarios in terms of dimension of the power plant, the photovoltaic plant that was needed to be used, and also the capacity of and the dimension of the storage. Is it possible to see immediately that in the first case, in the case where we tried to generate hydrogen network, the quantity of hydrogen that was needed was really too high, and it was out of the possible application, because there is really a problem of producing a photovoltaic plant so big, 21 megawatts, but also to have this so big storage of hydrogen. I see someone from the fire brigades here. I imagine that they are quite worried about this quite huge amount of hydrogen. But at the end, what we have seen is that for feeding scenario 2 and scenario number 3, it could be a possible solution, provided that the local conditions were sufficient to support the economic effort. There is a big problem, and it is something that I want to point out. I discussed it with all of the people this morning about this. The real problem is the use of an electrolyzer that is directly connected to the photovoltaic plant. If we do this, we have that our photovoltaic system will work for a number of hours that is quite low. So we have very high capex cost. So we decided in a second step of the analysis to try to feed the electrolyzer also with some part of the hydropower. So we examined 3 different configurations where we considered to use part of the electricity coming from hydropowers by assuming a number of different modulation based on the cost of the megawatt, so the so-called PUN, prezzo unico nazionale, a unique national price of the electricity. And when this PUN was above the threshold, all the production was given to the grid. Otherwise, part of the production could be used for producing hydrogen. So we analyzed the number of configuration, and what we have seen is that we were able to work in a more proper way by we have use of the electrolyzer for a longer period. And so from this point of view, this solution could result in a better solution. So I don't know why it is this. Here we have some results that are related to other, let's say, emission scenario and costs. Unfortunately, I have no time. I saw that I have just 1 minute. So I invite you to check all these results on the report that is present in the website of the Provincia di Trento. So what we can say is that we analyzed the feasibility. We have very interesting results in our point of view. We developed this model that could be used in a huge quantity of applications. And we have this control logic algorithm that is able to take in account how to modulate the production of hydrogen and the use of the renewable sources in order to optimize costs and minimize emissions and other. Just I want to spend a few words on the outcome that we have from this project, because after the development of the model, we understood that probably we need also an improvement of our model to take in account the problem of transportation of hydrogen, especially if we are considering the existing pipelines, where one of the big problems is that, of course, the hydrogen has a density that is much smaller than the natural gas. Then if we use the same pipeline and the same pressure, the power that we are transmitting we are transferring is much lower. So we analyzed the problem of increasing the pressure and also the problem of increasing power in the compressors when we move from natural gas to hydrogen. What we have seen is that, okay, we have some data here about the mass flow rate that is required in 3 different configurations, natural gas, blending, or hydrogen. But what I would like to point out is the increase in the power of the compressors related to the passage from natural gas to pure hydrogen. This is the blending. That is quite high, related to the fact that we have to increase the pressure, and also that it is much energy consumption. We have a much higher energy consumption if we pass from the natural gas to the hydrogen. So this is just to give you an idea of how this power increases. And finally, I have also the final application of the integration of the 2 models. We did a preliminary study assuming that we are producing hydrogen in Africa, in Tunisia, and we bring hydrogen from Tunisia through the South Corridor to the Taranto steel making. We analyzed all the process starting from production, transportation, and final uses, and we also, at the end of the story, we extracted the levelized cost of hydrogen from this type of solution. And what we can see is that if we obtain something that is closer to €6 per kilogram of hydrogen, if we produce hydrogen from green sources, and this cost is lower, but not so much lower, just half more or less, if we produce using steam methane reforming. This is something that we have already developed, we are testing, but it is almost finished at the moment, so it is something that we are interested in. So I can stop my presentation. Thank you very much for us. Pausa caffè? No, of course, if you have questions, we can discuss at coffee break.
No, we were just joking. There is no coffee break now. It was just a trick. to see if you are still alive. And torno all'italiano. No, comunque, grazie mille al professor Borello per la presentazione. Se ci sono domande, mi raccomando.
If you have questions,
c'è una domanda.
There is one question. Wonderful. Fantastic. Questions need to be made in a microphone in order to be translated. Otherwise, they cannot be heard. I have two very rapid questions. Going beyond what we all expect and the contribution of hydrogen with trucks, is it so that the local experiences that we saw have adopted strategies to widespread the usage of hydrogen in businesses, including the hard-to-abate sector, because they are energy-intensive businesses often. So the question is, have there been proactive initiatives to evolve entrepreneurs and businesses from the very start? The second question, equally fast to you, Professor, is about the hypothesis of creating a utility-scale renewable plant, devoting part of it to the production of hydrogen and the stockage of energy as an alternative to lithium batteries, or as an alternative to energy dome or the oxides that are on the market. So have you assessed these two things? First question was about actions to involve businesses, and the second question was about hydrogen to store energy for night use purposes. Devo tradurre la domanda?
I don't think I am the best person for answer to the first question, but as for the second, I try to answer immediately to the second. Okay, first of all, let's consider that hydrogen is a long-term storage. We could consider that the storage is different. Hydrogen and batteries are not the same type of storage, because batteries are okay for 3 days, 1 week maybe, but not more than this. And if we consider the application we had, we produced most of hydrogen during the summer and used during the winter. So there is no chance that we can have batteries for something like this. Okay, this is my first point. Second point, there are these problems and limitations related to Delegate Act about the production of hydrogen from renewable sources that is quite limiting in terms of producing hydrogen when the renewables are not available, and also the problem of additionality. We can produce green hydrogen only if we add new plants for producing the electricity to produce green hydrogen. In my point of view, it is a silly position. But of course, I'm not the one that is writing the rules. What I can say is that I think that Luigi told something about some sort of comment that were done to this. Let's hope that with the new commission something could change from this point of view, because otherwise hydrogen could have a very big problem, especially because in the United States these type of limitations are not existing. So the problem of a technology that is developed elsewhere is, it is just imported here, and we are just user and not producer anymore, it is quite big. So yeah.
Thank you very much.
In my opinion, we should produce hydrogen. We should use the electrolyzer for all the hours they can work in here, but it is just my position.
Alla prima domanda troviamo nella pausa caffè.
We will